Hi everyone, welcome to our discussion on chemical reactions. So this serves to answer the essential question, how do we know that a chemical change or a chemical reaction has occurred? For our learning targets in this video, we will be explaining how chemical reactions happen and will also be citing evidences of chemical reactions. So by definition, a chemical reaction is a process in which at least one new substance is produced as a result of a chemical change. Alright, so chemistry is all about producing new substances that are beneficial or helpful to improve the quality of life, to make manufacturing more efficient, and all other aspects of society. So what actually happens in a chemical reactions? The starting materials of a chemical reaction is called your reactants. Alright, so starting materials are your reactants. The resulting materials are your products. So in here, in order for a chemical reaction to happen, the reactants, the atoms or the molecules of the reactants must be given enough energy such that old bonds will be broken and new bonds will be formed. So this is where chemical bonding comes in. Again, in a chemical reaction, enough energy is supplied to your reactants such that the old bonds will be broken and it will be able to attract other atoms, thereby producing new bonds and producing new materials or new substances with brand new properties. So how do we know that a chemical reaction has occurred? Okay, or what are the evidences of a chemical reaction? So in here I have the illustration of the reaction of potassium metal with water. So potassium, the elemental potassium is a very reactive metal, especially when it is exposed into water. So in here, this shows us the reaction of potassium with water where the flame occurs because hydrogen gas H2 was produced, okay, by the reaction, and the hydrogen gas burns in air, okay, or it reacts with oxygen gas at high temperatures caused by the reaction. And so we say that one evidence of a chemical reaction is the evolution of gas. All right, the evolution of gas, and in here we can also see that there is energy that was released in the form of heat and light. Another evidence of a chemical reaction is shown in the ammonium nitrate and water reaction. So this is very familiar to athletes wherein you have cold packs or hot packs if you are having a sprain. So what actually happens there is when you break this or when you break that container, so the ammonium nitrate will be mixing with water, and what happens is the chemical reaction will absorb energy from the surroundings, thereby making your sprained foot or ankle colder. So in here we can see that there is a change in temperature upon reacting. So whenever you let two substances mix or react with each other, as long as you've noticed that it gets hotter or it gets colder, then we say that there is a change in temperature. So there is a chemical change or chemical reaction that is happening. The third evidence is shown in the reaction of lead nitrate and sodium dichromate. So in here you have a clear yellow solution being mixed or being poured into a clear colorless solution. And what is this cloudy material here or a foggy material here? Those are actually precipitate particles. So another evidence of a chemical reaction is the formation of precipitates. And what are precipitates? These are insoluble solids formed from the reaction of aqueous solutions, meaning these are solids that stay as is, so it's a resulting solid from two aqueous solutions. And they do not disappear or they do not get dissolved by water. All right? So there are actually a few rules in terms of the formation of precipitates. So it is given in this table or in any chemistry textbook where the solubility guidelines are found. So in here we have a list of soluble compounds and its important exceptions. So, for example, there for the chloride ion, so compounds containing chloride ions are usually soluble except silver chloride, mercury 2 chloride, and lead 2 chloride. All right, so this is how you interpret the table. Um, Compounds containing the bromide ion, so for example NaBr, are usually soluble in water except if you are having a silver bromide, a mercury 2 bromide, and lead 2 bromide. So these are very much repeated. For example, compounds containing iodine, okay, or the iodide ion. So for example, NaI, that's sodium iodide, they are usually soluble in water, but silver iodide, AgI, mercury 2 iodide, HgI2, and lead 2 iodide, PbI2, are not soluble in water. So when you talk about compounds containing the nitrate ions, let's say for example barium nitrate, they are generally soluble in water, meaning they do not form precipitates at all. The same thing happens with compounds containing the acetate ion, so sodium acetate, barium acetate, lithium acetate. So as long as you see C2H3O2, then they are usually soluble in water and they do not form precipitates. Now take note that those compounds that are soluble in water do not form precipitates. Okay, compounds containing these, except for their exceptions, do not generally form precipitates. What do form precipitates are the compounds containing the sulfide ions, the carbonates, the phosphates, and the hydroxide ions. All right, and here you can see their important exceptions. Okay, so for example, you have PbS. That's a combination of the lead ion Pb2 plus and the sulfide ion. So PbS is an insoluble compound, so meaning it can be a precipitate. Another one is mercury Hg2 plus, and then you let it react with the carbonate ion, so you will be having mercury carbonate. So that is another example of an insoluble compound, so it could be a precipitate. Another is magnesium. Magnesium 2 plus reacting with the OH minus ion forms magnesium hydroxide. So magnesium hydroxide is another example of an insoluble compound. Okay, and that could be a precipitate. In here we can see their important exceptions. So don't worry, this table will be used as your guide. So for example, we said a while ago that compounds containing the sulfide ion are insoluble. However, there are a few exceptions. So compounds of NH4 plus and the alkali metal cations like Ca2 plus. So for example, you have CaS or SRS, BAS. So these are soluble, these compounds are soluble in water. So we can just use this as our guide, okay? And we take note of the exceptions. So meaning to say, if it is under insoluble compounds, and then it says that it is an important exception for example, CaOH2, Ca open parenthesis, OH close parenthesis, sub 2, that is an important exception. So that means CaOH2 is soluble in water and therefore it cannot be a precipitate. All right. So that is for the solubility guidelines and rules for precipitation reactions. Again, the insolubles compound formed by these ions are the ones that can be considered as precipitates, excluding the exceptions presented in here. All right? So here is an example of a precipitation reaction. So this is the reaction of potassium iodide, Ki, and lead nitrate. So once that happens, once you mix them together, a yellow precipitate is formed, and once you leave it after a while, the yellow solids will settle at the bottom. So this is now our precipitate, and that is our lead iodide PbI2. And remember in the solubility rule, so if you have iodide, the iodide ion, and then they're usually soluble. However, if it's a compound between lead and the iodide ion PbI2, then it is an exception. Therefore, it will not be soluble in water, and therefore it is a precipitate as what is presented in here. All right. Meanwhile, the other product, potassium iodide, is soluble in water, so it doesn't form solids at all. So, as a recap or a review, how do we know that a chemical reaction has occurred? So, first, if there is a formation of a precipitate. Second, if there is a formation of bubbles or evolution of gas. Third is generation of heat or light or change in temperature. So, in the case of exothermic and endothermic reactions. A change in color or odor can also be considered an evidence of a chemical reaction, right? So that ends our video discussion for today. And stay tuned for our discussion on chemical equations, which is practically understanding and using chemical language. So take a break first and have